Assalamualaikum and hi everyone. For those who are watching this video, this is a presentation assignment for CHM301 about aspirin from group A4AS120513. So next, this is our team. The first one is Nur Laila Masara binti Azman. The second one is Nur Safira binti Muhammad Khairi. The third one is Farah Damia binti Zamri, and last one is Khairul Danish Irfan bin Haidar Azam.
Hi everyone, my name is Nur Laila Maisara binti Azman. Now I'm going to tell you about aspirin. Aspirin, or also known as acetyl salicylic acid, was first synthesized in 1897 by Philip Hoffman. He is a chemist at Bayer's who sought a less irritating alternative to salicylic acid for his father's rheumatoid arthritis. Its medicinal use dates back to ancient time when extract from pillow bark and leaf, which also rich in salicin, that were used for pain relief and fever reduction. There's also a fun fact about aspirin, which aspirin is the first drug to be produced and marketed in tablet form. Prior to this innovation by Bayer in 1915, most medicines were administered in powder form, liquid form, or by other less convenient method. Now, we will move to the structural formula of aspirin. First, we can see the functional group that called benzene ring, or also known as aromatic in homolog series. Benzene ring, an aromatic functional group characterized by a ring of 6 carbon atoms bonded by alternating single and double bond. Next, we can see the functional group is carboxyl, or also known as carboxylic acid in homolog series. Carboxyl group are a combination of two functional groups attached to a single carbon atom, which is hydroxyl and carbonyl. Last but not least, we have a functional group known as carboxyalkoxy, or also known as ester in homolog series. Carboxyalkoxy is a radical that consists of carbonyl combined with alkoxy. The chemical formula for this structure is C9H8O4. The IUPAC name for this structure is 2-acetobenzoic acid. The common name of this structure is aspirin.
Moving on to physical and chemical properties of aspirin. Starting with physical properties, we have first appearance, which is aspirin is typically found as white crystalline solid powder. It can also be available in tablet form. Second is melting point. The melting point of aspirin is approximately 136 Celsius or 277 Fahrenheit. This property is crucial for its formulation and stability during manufacturing. Next, pH is an aqueous solution of aspirin are slightly acidic. The pH of a saturated aqueous solution of aspirin is around 2.5, which reflects its carboxylic acid functionality. As solubility, aspirin is sparingly soluble in water. With solubility increasing slightly in warm water, it is more soluble in organic solvents such as ethanol and chloroform. Now, for chemical properties, we have acidity, which is aspirin is a weak acid with a pKa of 3.5, primarily due to the carboxylic acid group COOH in its structure. This property influences its solubility and absorption in the biological environment, as it tends to be more soluble in basic alkaline conditions than in acidic ones. Next is photochemical decomposition. Aspirin is susceptible to degradation upon exposure to light. This will lead to the decomposition of the acetyl salicylic acid and the formation of products such as salicylic acid, which may reduce the efficiency of the drug. Last, reactivity with strong bases. Aspirin can react with strong bases to form water-soluble salt. And when aspirin is treated with sodium hydroxide, for instance, it forms sodium acetylsalicylate. This reaction is utilized in some formulation to enhance aspirin solubility and hence its bioavailability.
There are many benefits and uses for aspirin. Firstly, aspirin can be used as the pain relief. Aspirin is effective in reducing pain from various sources such as headache, muscle aches, and toothaches, due to its ability to inhibit enzymes involved in pain and inflammation. Secondly, it can be used as an anti-inflammatory. Aspirin is frequently used to reduce fever. This is achieved through its action on the hypothalamus, the part of the brain that regulates body temperature, leading to peripheral blood vessels dilation and increased perspiration, which help cools the body. Aspirin can be used as the cardiovascular protection. One of the significant uses of aspirin in the medical setting is its role in the prevention of heart attacks and strokes in individuals who have already had one or are at high risk of such events. Aspirin inhibits platelet aggregation, thus preventing the formation of blood clots in arteries. Besides that, it can also be used as the prevention of colorectal cancer. Long-term use of aspirin has been linked with a reduced risk of developing colorectal cancer. The exact mechanism is believed to involve the inhibition of the cyclooxygenase 2 enzyme, which plays a role in tumor growth. Lastly, aspirin can be used as the prevention of preeclampsia. Low-dose aspirin is recommended for pregnant women at high risk of preeclampsia, a condition characterized by high blood pressure and damage to other organ systems.
So next is chemical test. For the first one, the synthesis of aspirin is esterification reaction, where alcohol react with acid derivative to form ester. For the reactants, salicylic acid C7H6O3 contains a hydroxyl group attached to a benzene ring, and acetic anhydride CH3CO2O, a derivative of acetic acid that acts as the acetylating agent, and for the catalyst is sulfuric acid H2SO4 is speed up the reaction without being consumed. And the reaction process is the hydroxyl group on salicylic acid react with acetic anhydride. This can form aspirin and acetic acid as a byproduct. And for the reaction equation is C7H6O3 plus CH3CO2O, and the product C9H8O4 plus CH3COOH. The reaction involves replacing the hydroxyl group of salicylic acid and with acetyl group. Aspirin is purified by crystallization after the reaction. The second one is hydrolysis of aspirin under acidic and basic condition. Aspirin C9H8O4 can break down into salicylic acid C7H6O3 and acetic acid CH3COOH when exposed to water in acid or basic environments. For acidic conditions, the reaction is speed up by acid, for example hydrochloric acids, and for the basic condition, the reaction is catalyzed by bases, for example is sodium hydroxide. And for the reaction example is C9H8O4 plus H2O, and the product is C7H6O3 plus CH3COOH. So this shows aspirin reacting with water to produce its hydrolysis product. And the last one for chemical test is reaction of aspirin with ferric chloride. Is a phenol test. When aspirin react with ferric chloride FeCl3, a purple complex is formed. This happens due to the presence of salicylic acid either as an impurity or formed by hydrolysis. The phenol group is OH is a salicylic acid interact with Fe3 plus ion to produce the color compound. And for the reaction example is C7H6O3 plus FeCl3, and the product is Fe C7H5O33 plus 3HCl. So here is a salicylic acid react with ferric chloride to form a ferric salicylate complex and hydrochloric acid.
In conclusion, aspirin is synthesized by Philip Hoffman in 1897 to find a better alternative for his fatty disease. Next, there is three homologous series and functional groups that are present in aspirin, which is carboxylic acid, ester, and aromatic. For its physical properties, aspirin is commonly found as a white crystalline powder. It also has a low pH which aligns with its carboxylic acid functionality. Aspirin also have high melting point, which is 136 degrees Celsius, which is important for the manufacturing. And for the solubility aspirin is partly soluble in water. Aspirin with acidic pKa of 3.5 and photochemical composition make it prone to breakdown in presence of light. It will potentially diminishing in medication effectiveness. Aspirin can also combine with strong base to create salt that is soluble in water. Aspirin has several benefits and use, including the ability to reduce pain, inflammation, protect the cardiovascular system, prevent colorectal cancer, and prevent preeclampsia. The chemical reaction that lead to the creation of aspirin when acetic anhydride and salicylic acid combine. The next one is aspirin hydrolysis, which occur when aspirin react with acetic or basic substance. It will form salicylic acid and acetic acid again. Last but not least, aspirin and ferric chloride combine will generate a purple complex because the presence of phenyl group.
So this is list of our reference, and that's all from us. Thank you.